Okay, I'm going to attempt to get this done before my kids wake up from their nap. Okay, so if I end up having to do more than one video, I apologize. Okay, so I understand that I'm not there and it's kind of hard to understand. I'm hoping that the more you practice, the more you'll understand it. And I promise that I will make sure that you're given plenty of time to make up for me not being there. So, okay, so a quick review. So we're gonna go, and if some of these end up taking a bunch of space, I'm gonna do it on another sheet of paper, so it's not so jammed in one spot. Okay, so you can multiply those two. Okay, so we get the square root of 48. Then remember, oh, I think my daughter got rid of my perfect squares. You remember your perfect squares. So we've got 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. Hopefully that will be enough. Okay, so we're going to find one of these numbers and another number that multiply to get 48. So if we do 48 divided by 12, or by 4, let me show you that. Well, hold on. Let's just go ahead and do. It's not going to be 4 would work, but 16 would be a better option. That's why I would go 48 fits here, so then try 36, 25, 16, 9, 4. So let's do 48 divided by 16 is 3. So this breaks into square root of 16 and the square root of 3. So these are still the same thing as this, but now square root of 16 becomes 4, square root 3. Okay? All right, kind of the same thing here. So let's go 5 times 15, square root of 75. Well, 75 fits here. Nope, that doesn't go in. Nope, nope, yes. So 25 and 3, 25. Square root of 25 becomes 5, square root of 3. Okay? Okay. Then, when you're dealing with things like this, we're still going to break the 32 into something, okay? So 32 fits here, 24 doesn't go in, 16 does go in. So square root of 16, square root of 2, okay? Then we have a set of r's that can come out. So hold on, let's go back to the 32. So the square root of 16 is 4. It's going to be on the outside of the radical. I'm just going to leave a little bit of space. The 2 is still in the radical, so we have to put it there. Then r squared, if I had r, it would be a set that could come out, so I'm going to do the r. K would have 2 sets, and then t would have 2 sets with 1 still left in here. So that's going to be your answer. Okay, and I know some of these were from the second part of yesterday's notes. I'm just kind of going over things again in case you didn't see it. Okay, so we have a couple options here. The easiest one might be if they're both under the radical. If these can be reduced, I would go ahead and do it, because then that would help just a little bit in how much you actually have to do. So 35 and 15 can both be reduced by 5. So that becomes, I'm going to rewrite this, 7 over 3. Okay? So then that becomes square root of 7 over the square root of 3 now. So I'm going to start it again over here. Square root of 7. And remember what I said yesterday, you can't have a radical or this square root on the bottom. And the best way to get rid of it is to multiply it by itself, because then it becomes the square root of 9, which is 3. So basically, once you multiply this by itself, it just becomes the number that's under the radical by itself. So then on top we have 21, and on the bottom we actually just have 3. Okay? And because one of these is under the radical and the other one is not, you cannot reduce those. Okay? So then once again, let's see, and this could be considered one radical, so let's reduce those. So we'll reduce that by 6 and that by 6 as well. So it's the square root of 1y, or just y, and the square root of 2. Then again, we're going to multiply by itself, the bottom one by itself. And in doing that, if we have this is just 1. And remember, multiplying by 1 doesn't change anything. Doesn't change the value of anything. So then the top, when we multiply these, is square root 2y, and then on the bottom it's going to become 2. So hopefully we remember those. Okay? All right. So this part, sometimes it's really hard to rationalize, which is what you're doing when you multiply it by itself, because now we have two terms. So now we have to multiply this whole thing by 5. We're going to multiply it by itself, but change the sign, and I'll show you why. Same thing has to happen here. So 5 minus square root 2. Okay? So let's just look at the bottom and let's see why. So this is going to have to be, you're going to have to distribute. So we're going to look at the 5 alone. So 5 times 5 is 25. Then 5 times negative square root 2 is negative 5 square root 2. Now we're going to do this one. So we'll multiply this by this. And that's going to be positive 5 square root 2. And then square root 2 times negative square root 2 is going to be negative square root 4. And I apologize if that's so close. Okay. So I think, let's see. And then on top, we're going to have 3 times 5 is 15 minus 3 square root 2. Okay, so now I'm going to rewrite this down here. So I have 15 minus 3 square root 2 over, well, if you look here, and let me move this a little bit closer. If you look right here, this is a negative 5 square root 2 and a positive 5 square root 2, so those actually get rid of each other. Okay? So now we have 25. Actually, I'll just rewrite the whole thing. 5 square root 2 plus 5 square root 2 minus square root of 4. Okay, so this right here is just what this says, but it's not squished. Okay? So, again, these two things are opposites, so now they're gone. Okay? So now it becomes 15 minus 3 square root 2 over 25 minus the square root of 4. Well, the square root of 4 is 2. So 25 minus 2, so we're going to come back over here. So we have 15 minus 3 square root 2 over 25 minus 2. So 25 minus 2 is 23. The top, 15 minus 3 square root 2. Okay? And I know this looks crazy, but this is the answer. The only way this wouldn't be the answer is if all these numbers outside of the radical could be reduced by something, but 23 is prime, and so you cannot reduce it by anything. So this is just going to take some time learning the process, okay? So I'm going to use another sheet of paper to do this second one so that you can see better. Let's see. All right, so here we go. We have 3 over 2 plus square root 2. Okay, so then you have to multiply it by the exact same thing except a minus in here. So, and that the minus is the whole reason we were able to get rid of these middle things. So that's why we do it. Okay, so on the top, we have 6 minus 3 square root 2 over, so let's do the long part. 2 times 2 is 4. And then 2 times negative square root of 2, so negative 2 square root 2. Then positive 2 square root 2 minus square root 4. Okay. So then let's come down because we have more space. So we have these get taken care of. So we have 4 minus, well, that's a 2. So that's 2. So 6 minus 3 square root 2, that was the top, over 4 minus 2, which is 2. Now, if you look here, those could reduce, but that one cannot. And because that one cannot, you can't do it. Okay? And we won't have a whole ton of these kind because it is a difficult process. So, okay. So now I want you to try that one yourself. Go ahead and pause the video. Okay, so now we're going to multiply it by opposite sign. Okay, so now we are at 21 minus 7 square root 7. Then on the bottom, we have 3 times 3 is 9. And then this one's the opposite sign that we've been used to doing. So it's going to be plus 3 square root 7 minus 3 square root 7 minus square root 49. Okay, so now we're going to bring this and continue right here. Okay, so we have 21 minus 7 square root 7. Remember, the middle ones go away. Square root of 49 is 7, so we have 9 minus 7, so we have 2. None of these things can reduce, so that is it. See, it gets a little bit better the more you practice it. Okay, all right, so now something a little bit easier. When you have radicands, which is what these are called, okay, you cannot put things together unless they are the exact same number under here. So we have square root 2, square root 2, square root 2. It's kind of like a variable, okay? So we have 5 plus 7, which is 12, minus 6, which is 6. So the answer is 6 square root 2. That seems awfully easy now, huh? Okay. So then we have 7, 7, 11, 11. And neither of these can be broken. So all we can do is put this together with this one. So we have 10 plus 4. So we have 14 square root 7. Then we have 5 minus 6 is negative 1 square root 11. And those can't be put together, so there's your answer. Okay. All right. Sorry, that's the old paper. Okay, so now we're going to look at something like this. Okay, which I believe this was on that last page of the last notes, but we didn't need to do. Okay, so we have 18, 32, 72. So clearly it would seem that these can be reduced. So So I'm going to pull out my perfect square paper. And we're going to look at that. So let's move this down just a little bit. Again, my apologies. Okay, so there's my perfect squares. So 18, well, 18 would fit here. 16 can't go in, so 9. So we have, and just pay attention to everything that you've got going on. So we have square root of 9, square root of 2, okay? So the square root of 9 is 3, so we have 3 square root 2, but don't forget that this was out here. So 2 times 3, so we have 6 square root 2. So now we've dealt with that one. So then 32. Well, 32 fits here, so 25 doesn't go in, so 16 it actually does. Square root 16, square root 2. So then square root of 16 becomes 4, square root 2. Make sure you bring down your 2, and it was positive. So 2 times, so plus 8 square root 2. And then 72, actually 36 goes in, because we're really trying to get them to be the square root of 2's, so we can put them all together. So we have the square root of 36 and 2. So 36 becomes 6 square root 2. There wasn't a number out here, or it's an understood 1, so we can just leave it. So plus 6 square root 2. So they're all the same. So now we have 6 plus 8 is 14, plus 6 is 20. The answer is 20 square root 2. Okay. All right. So now, let's see. Here we go. So, same thing. So let's look. 45. Well, we know 9. Square root of 9. Square root of 5. So 3 square root 5. Bring that down. So 3 times 3. 9 square root 5. So that one's done. This one is going to be square root of 4. Square root of 5. We've got 2 square root 5, nothing really outside, so it's just plus 2 square root 5. Then we're going to see if 245 can be divided by 5 and get a perfect square, because we want it to be this square root of 5, and it's actually 49. So 49 and 5, so 7 square root 5. Now make sure that you don't drop this negative, so it's a minus 7 square root 5. So now they're all 5s. So 9 plus 2 is 11, minus 7 is 4. So 4 square root 5. Okay, and I think we're on our last slide. Okay, multiplying radical expressions. Okay, still using our perfect squares. Actually, these ones, kind of, yes. Okay, so these, you can just multiply the outsides. So we have 14, and then we have 6 times 3, which is 18. Well, this can be broken down into 9 and 2. So then the square root of 9 is 3, square root 2, and then let's bring the 14 down. So 14 times is 42. Square root 2. There you go. Those tend to be a little bit easier. Okay, so now this one, we're going to distribute it. So let's look here. So 3 times 4 is 12. 2 times 3 is 6. Then we're going to add. Then we have 3 times 6 is 18. 2 times 2 is 4. Okay, so then we have 12. Square root 6. Well, square root of 4 is 2, so then it just ends up being 18 times 2, which 12 square root 6 plus 36. And this can't be put together because there isn't a radical right there. So it's kind of hard to understand all the different rules, and we will practice and practice and practice, okay? All right, and then there's the assignment.